Hello everyone, welcome to Physics on Table channel. So, my objective is to discuss the syllabus of IIT JAM Physics. So, let's discuss the syllabus today. Our syllabus is like this. We have mainly seven portions. First one is mathematical physics. Second one is mechanics and general properties of matter. Mechanics is very important. We have waves of oscillation and optics, electricity and magnetism, kinetic theory of gases and thermodynamics, modern physics, solid state physics and electronics. Okay, so let's discuss our syllabus, what is important and which portion we're going to give more preference and importance, and it's going to be scoring for us. So first, the syllabus is about mathematical methods. It is calculus of single and multivariables, partial derivatives, Jacobian, imperfect and perfect differentials, Taylor expansion, Fourier series, vector algebra, vector calculus, multiple integrals, divergence theorem, Green's theorem, Stokes theorem, first order equations and linear second order equations, differential equations with constant coefficients, matrices and determinants, algebra of complex number. So if I need to emphasize what is important and what is not, I'm telling you from mathematical physics, vector algebra is very important. Okay, we'll get questions from vector algebra. So this portion is very important. Vector algebra, vector calculus, multiple integrals, the theorems, followed by differential equations and matrix. These three portions are very important. Okay. First portion is not so important, calculus of single and multiple variables, though we are going to cover that. But these three portions is very important. And sometimes you can get question from Jacobian. It will take a single class for that, and partial derivatives not so, and complex number is not so important, but we're going to cover everything, but I'm just speaking about the important things. Okay, so let's come to the next portion. Next portion is mechanics and general properties of matter. This portion is very important. Each and everything is important because any type of problem may come. Okay, let me wrap these things. Yeah, so what is Newton's laws of motion and applications, velocity and acceleration in Cartesian, polar, and cylindrical coordinate systems, uniformly rotating frame, centrifugal and centrifugal and Coriolis forces, motion under a central force. Most important portion is central force. Kepler's law, gravitational law, and field, conservative and non-conservative forces. Some conservation type of problems may come like energy, momentum, like this. System particles, center of mass, equation of motion of the center of mass, conservation of linear and angular momentum, as I was saying, conservation of energy, variable mass systems, elastic and inelastic collisions. This portion is next important. uh, RBM, that is rigid body motion, fixed axis rotation, rotation and translation, moment of inertia and products of inertia, parallel and perpendicular axis theorem, very important, spatial principal moments and axis, kinematics of moving fluids, equation of continuity, Euler's equation, and Bernoulli's theorem. So what is important? Newton's laws and motion are very common. I hope you have done this in your plus 2, right? That's class 11 and 12. Velocity and acceleration in Cartesian, polar, and cylindrical. This is a very basic chapter. You have to study this for studying various systems. That it is very important. Uniformly rotating frame and centrifugal, yeah, a problem might come. You have just some of the standard formulas. You have to memorize it and need to attack the problem. That's enough. Yeah, we're going to cover the concept as well. Obviously, that is very important. Motion under a central force. This is very important. You can't leave this portion because questions will come from this portion. I'm sure about this. You can go through the previous year papers. K plus law is very important. That third one is very important. Gravitational law and field, yeah, and conservation systems are very important. Center of mass, rigid body motion, yes. And from kinematics, that standard formula Bernoulli's equation, that one is important. Okay, so let's go to waves oscillation optics. This portion is easy. You don't need to go through that big derivations as you do in your BSc, in your semester exams. Just you need to memorize the formulas. That is important. Lisa's figures are there. Let me tell the syllabus. Differential equation for simple harmonic oscillator is general solution. Okay, x equals to a sin omega t plus 5, the phase difference, whatever you say. Superposition of two or more simple harmonic oscillators. Lisa just figures damped and force oscillators, resonance, the condition of the resonance, amplitude and velocity, they are important. Sometimes you can get about that critical damping and like this, they will ask you the conditions. Okay, you have wave equation, traveling and standing wave. Just read the formula velocities in longitudinal transverse mode. V is equal to root over t by m, like this, and y by rho root over, yeah. Okay, energy density and energy transmission in waves, yeah. So just read the energy density in both standing waves. Average energy transmission is 0 in standing waves, and traveling there is an equation. We are going to cover this. This is very important. Group velocity and phase velocity. There are many formulas, not just two. I will obviously discuss that. Sound waves in media. Intensity problem may come, may not arrive, I don't know. We are going to cover it. Doppler effect is important. Doppler effect is very important. That standard one or two formulas are there. With just one or two formulas we can do each and every problem, and there are some formulas from equation and from the problems and all. We're going to cover that. Fermat's principle is important. Okay, this year, I mean 2021, a problem came from here. General theory of image formation. This portion is not so important, but this is the first time this portion was given high importance from IISc. I don't know why. Thick lens, thin lens, yeah, thin lens combinations. Okay, standard problems are okay, but they have given very high importance from this portion. Many people are unable to do that. So it varies from institute to institute. We don't know what the next institute or other institutes are going to do. Whatever we are going to cover everything, and let's not overthink, right? Interference, optical path retardation. Optical path retardation is important. There will be some interference pattern. They will just give you the value of diffractive index and you have to proceed. They will just insert a bar giving a refractive index. You just need to find that shift of the central fringe and all. We're going to cover that. Fraunhofer diffraction is important. Rayleigh criterion and resolving power. Fresnel is not here, so you have to read a little less. Diffraction grating is very important. That width and resolving power. Okay, these are important. Polarization is very important. Linear, circular, elliptic, double reflection, and optical rotation. There are some standard formulas and what type of orientation occurs when linear to what plate we need to use to convert linear to circular. There are some standard formulas, lambda by 4, and like this. Okay, so let's go to the next page. Here we have, okay, let me discuss first about electricity and magnetism. This portion I have separated because this is the most important portion. equally to classical mechanics. Okay, so from electricity magnetism, everything is important. I can't comment on this. See, you have Coulomb's law, Gauss law, electric field and potential, electrostatic boundary conditions, solution of Laplace and simple cases. For simple cases, conductors, capacitors, dielectric polarization, volume and charges, electrostatic energy, Biot-Savart's law, Ampere's law, Faraday's law, self and mutual inductance. Each and every portion is important. You can't leave this. Okay, I can't say this portion is important and that portion is not. You have, this is very important. Alternating currents, simple DC and AC circuits with RL and C components, displacement current, Maxwell equations, and plane electromagnetic waves, Poynting theorem, reflection and refraction at a dielectric interface. There's some standard formulas with the refractive index. It's easy. You have only normal incidence. That's very good, and it makes the formula more easier. Transmission and deflection coefficients, Lorentz force, that QV cross V plus QE, that one, and motion of charged particles in electric and magnetic fields. Okay, this portion is very important. We are going to cover this and also going to solve many problems from here. Okay, next portion, kinetic theory and thermodynamics. Where is coding portion? Entropy is very important from this part. Elements of kinetic theory of gases, velocity distribution and equipartition of energy. Many things are written. What they give is that some standard problems from degrees of freedom or specific heat problems may come. See, here it is written specific heat of mono, di and triatomic gases, ideal gas, van der Waals gas, and equation of state. They've written many things, but mainly velocity distribution, that some standard formulas, root over RT by M at RAM1, average, mean. Okay, I think you can understand what I'm trying to say. Mean free path is important. Yes, it 1 by root 2 1 formula, pi n d square, like this, whatever I need to check. Laws of thermodynamics, zeroth law and concept of thermal equilibrium, first law and its consequences, isothermal and adiabatic processes, reversible and irreversible quasi-static process. These portions you have gone through in class 11 or 11, right? Yeah, we have in class 11 thermodynamics and physics. I've gone through it. Easy portion. We're going to read that only. Nothing more is there. Second law and entropy Carnot cycle. There are 4 types of entropy problems. We are just going to discuss that 4 portions. You will get 1 type in exam, sure. Maxwell's thermodynamic relations. There is a shortcut to remember this. I have already made a video on that. You may check. Simple applications, thermodynamic potentials and applications, phase transitions, and Clausius-Clapeyron equation. Important standard problem may arise. Ideas of ensembles, very easy portion. Don't leave statistical mechanics. We'll get a problem from here, mainly that Fermi energy type problems. Yeah, that may come. Then Maxwell-Boltzmann, Fermi-Dirac, and Bose-Einstein distribution. For kinetic theory and thermodynamics, just follow one book, Garg-Bansal-Ghosh. I followed that. Now let's go to modern physics, one of my favorite one. You have inertial frames and Galilean invariance, postulates of special theory of relativity, Lorentz transformation, length contraction, time dilation, relativistic velocity addition theorem, mass energy equivalence. From Lorentz transformation to mass energy equivalence, everything is important. We have black body radiation, photoelectric effect, quantum effect. From photo and quantum, just remember the standard formulas. Black body, that Rayleigh-Jeans and Wien's laws, and also Planck one. Important, mainly photo and quantum are more important. Bohr's atomic model, just read hydrogen here, and you know you have studied this in class 11 chemistry first chapter or second chapter, I think. Yeah, atomic model, Just you have to remember some standard formulas. There are some big formulas like kinetic energy, potential energy. You have total energy. Then you have to find velocity, radius, right? Just there are some standard relations. With practice, you are going to be a master in it. X-ray, wave particle duality is important. At matter wave, yeah. Uncertainty principle is very important. You know this. The superposition principle, yes. Calculation of expectation values, Schrodinger's equation, and a solution for 2 and 3 dimensional box. 1, 2, and 3. Okay. Then three types of three-dimensional box is very important. 3 and 1. 2 sometimes question may arise. Just you need to study this. Not so hard as it is. It might seem that what is written who are seeing this syllabus for the first time, but it's not that tough. Okay. Solutions of Schrodinger equation for the one-dimensional oscillator. Here it is written one-dimensional, right? It's not only one-dimensional. You have to study it in three-dimensional as well, and two-dimensional as well. That energy eigen equation, eigenvalue. Reflection and transmission at a step potential, yes, important. Pauli's exclusion principle, not so. Yeah, a basic thing is very important, that 2s degenesis is 2s plus 1. Just a basic thing is important from Pauli's exclusion principle. Structure of atomic uh, nuclear mass and binding energy. Nuclear physics is important. Some students leave it and go to the exam, but I don't suggest you to do that. At least read. I myself is interested in nuclear, and at present I have taken it as my elective from where I'm doing my master's till now. Radioactivity and its application, the laws of radioactive decay. Okay, and this syllabus I have already discussed and make a video on it. Sorry I couldn't continue the series due to some personal reasons. I will try to continue this time. It's solid state physics, devices and electronics, crystal structure, various lattice and basis, Miller indices, X-ray diffraction and Bragg's law, intrinsic and extrinsic semiconductors, variation of resistivity with temperature, Fermi level, PN junction diode, IV characteristics. What is important from up to this is crystal structure is very important. You are going to study various type of structures. You have to remember those structures and also the CN, that is coordination number and all. X-ray diffraction is very important. That formula 2d sin theta equals to m lambda. Intrinsic and extrinsic semiconductor, obviously band graph are important. Variation of resistivity with temperature, graphs, standard graphs are there. Just to read that. Fermi level, yeah, it's included in band theory. PN junction diode, IV characteristics. Okay, you have Zener diode. Zener diode, there are some standard problems. We're going to discuss that. You will get questions from this discussed problem in the class. BJT, you have to write the characteristics, single stage amplifiers, two stage amplifiers. This portion is not so important, but you know it varies from institutes to institutes, so we are going to cover everything. Simple oscillators, Barkhausen criterion, A beta equals to 1. Sinusoidal oscillators, there are many types of sinusoidal oscillators. We need to remember that value of M and L, C, yeah. Yes, I have studied this. Op-amp and applications, inverting and non-inverting. Not only inverting and non-inverting, there are many: summing, differentiator, integrator, subtractor. You have to cover everything. And Boolean algebra is very easy, and you have just very small amount of digital electronics, binary number system, conversion from one system to another. I have made some video on it. I hope you will see that videos. From one system to another, binary addition and subtraction, logic gates, and or not, exclusive NOR, XNOR, everything is important. Truth tables, combination of gates, Karnaugh mapping is also important. It's not written, but it's very important for shortcut method. And De Morgan's theorem, you know this, I hope. Studied this in class 12 digital electronics. Yeah, it was there. So this is all syllabus discussion. I hope the syllabus is clear to you and you have noted down the important portions, what is most coding and what is more emphasizing. For coding, I can say mathematical methods is coding, modern physics is very coding, solid state physics is coding, KTG, thermal physics, thermodynamics is physics coding. For classical and EMT, we people just need to give some effort. Okay, we are going to cover it. So let's begin the journey. All the best. So I'm going to teach you from the next class. So hope you people will join. Thank you.